Hey everyone, it's Miss Grace. Today we are going to be using our distance formula to classify quadrilaterals. First thing we need to do, we need to check the congruency of the sides. So we're seeing if all of the sides are equal, or if two of the sides are equal, or none of the sides are equal. We're checking congruency of sides, and then we're also going to check the congruency of the diagonals. So if we recall properties of our quadrilaterals, when we talk about parallelograms, opposite sides are congruent, diagonals are not congruent. So opposite sides are congruent, diagonals are not. For rectangles, opposite sides are congruent. The diagonals are also congruent. So if I look at this side, it is congruent to this one. This side is congruent to this one. And then my diagonals are congruent to each other. For a rhombus, all four sides are congruent. The diagonals are not congruent. So I just want to double check. So all four sides are congruent to each other. So they usually will mark like that, and I can do the same thing. With my rectangle parallelogram, I should have marked my little and then for a square, last quadrilateral, we're talking about all four sides are congruent and the diagonals are congruent. So all four sides are congruent to each other. So we put a little dash. Then the diagonals are congruent to each other. So those are the same. So looking at the first example, so we're going to use our distance formula. And just as a reminder, distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to use that. We're going to use it for sides. And we're also going to use it for diagonals. So we're going to be doing the distance formula quite a bit for each of our examples. So for this first one, again, doing sides first. And to kind of help us know, like, what letters go with what sides, I will draw out a quadrilateral. It doesn't matter what your quadrilateral looks like. So I'll have side AB, I have side BC, I have CD, and I have AD. So looking at AB, here's X, here's Y, X, Y. So my second X is 2, or sorry, my second X is 8, minus first X is 9, plus second X is negative 2, first X is negative 4. Now, if you remember, we need to be very careful when we put this in our calculator. So we're going to do second, the square root button, and it already comes up with a parenthesis. I'm going to add in a second parenthesis. Then I'm going to do 8 minus 9, close my parentheses squared, plus -2 minus a -4, close my parentheses squared, and then equals. So 2.24. Now we're going to do the same thing with BC. So from B to C, here's my X, here's my Y. Second X is 2. First X is 8. Second Y is -5. First Y is -2. Then again, we're being really careful when we put it in our calculator that we're adding in that second parenthesis. CD, X by Y. CD, so my second X is 3, first X is 2. Second X is -7, second Y is -5. That should give me 6.71. All right, last side, I have AD, so from A to D, second X is 3, first X is 9, second Y is -7, first Y is -4. So looking at just the sides, I have opposite sides. So if I look at AB and CD, AB, CD, those opposite sides are not congruent. Or I should say, sorry, opposite sides are congruent. AB, CD, opposite sides are congruent. So opposite sides congruent. So I could have a parallelogram or I could have a rectangle. All right, now we have to do diagonals. So my diagonals are going to be AC and BD. Here are my diagonals, AC or BD. So I'm going to look at AC first. Going to do distance formula. We have 2 minus 9 squared plus -5 minus a -4 squared. Gives me 7.1. So we did AC, now we have to do BD. Distance formula. That also gives me 7.1. So looking at the sides, I have opposite sides that are parallel. Or sorry, opposite sides that are congruent. My diagonals are also congruent. So diagonals congruent, opposite sides congruent. I'm going to look up here, opposite sides congruent, diagonals congruent. So this is a rectangle. All right, flipping our page. Again, I'm going to draw in what my parallelogram is going to look like. So it's going to help me in determining what my sides are. We're going to do the same thing. We're doing distance formula for the sides. So I have QR, I'll have ST, I'll have QT, and I'll have RS. What I did is I just looked at the opposite sides and I kind of paired them together. So looking at QR, I have 1 minus a negative 2, minus a negative 2. I can, for this time, I'm just going to say plus. You can put in minus a negative. Then I have negative 5 minus a negative 7. Minus a negative makes it a plus 7. And this is 3.6. Now I'm going to go with ST. I have 1 minus 4. The 4 is a positive, so I want to make sure it's just a minus the positive. Plus negative 9 minus a negative 7 minus the negative makes it a positive 7. This is also 3.6. For QT, I have 1 plus 2. So it's 1 minus the negative 2, which makes it a plus 2. And I have negative 9 plus 7. Negative 9 minus the negative 7 makes it the plus 7. That is also 3.6. And then last side, I have 4 minus a positive 1. So I'm going to keep it minus. Then I have negative 7 minus the negative 5 makes it a plus 5. That is also 3.6. So looking at this, all 4 sides are congruent to each other. So if I flip over to like my little cheat sheet, looking at all 4 sides are congruent. It could be either a rhombus or a square. So I'm thinking rhombus or square. Now I have to do the same thing with diagonals. So my diagonal is going to be TR, QS. Again, doing my distance formula. So I have 4 minus negative 2, which makes it the plus 2. Negative 7 minus a negative 7 makes it a plus 7. That actually comes out to be a whole number of 6. I'm not going to get a decimal. Then TR, I have 1 minus 1 squared plus I have negative 9 minus a negative 5 makes it a plus 5. And this one also just comes out to be a whole number of 4. So I'm going to look either at my cheat sheet or I'm going to ask myself which one has the diagonals of not congruent. All right, the quadrilateral that has diagonals not congruent, but all 4 sides would be my rhombus. All right, last quadrilateral that we're going to do. Again, draw your picture. J, K, L, and N. I'm going to look at opposite sides, kind of pair them together. So JK, ML, JM, KL. Do distance formula. When we're doing this, we're putting in double parentheses at the beginning. So 8 minus 5 squared is minus a positive 5. Oh, sorry, I have the wrong. Sorry, everyone, I'm looking at the wrong sheet. Still same idea. Opposite sides, so WX, ZY, WZ, and XY. Now that I have the right letters and I'm looking at the right points, x2 minus x1, so I have 1 minus a negative 4 makes it a plus 4. y2 minus y1, negative 2 minus a negative 1 makes it a plus 3. Get my final answer. I'm getting 5.1. For ZY, I have negative 3 minus a positive 2 plus negative 8 minus a negative 7 makes it a plus 7. So that is also 5.1. Negative 3 minus a negative 4 makes it a plus 4. Negative 8 minus a negative 3 makes it a positive 3. Then for the last side, I have negative 2, or sorry, positive 2 minus a positive 1. So I'm going to keep it the minus. Plus negative 7 minus a negative 2 makes it a plus 2. It's 5.1. Again, I have all 4 sides that are congruent, so my options are going to be either the rhombus or the square. Now I'm going to look at my diagonals. So I have ZX and WY. do distance formula for your diagonals now. So for WY, I get 2 minus -4 makes it a +4. -7 minus a -3 makes it a +3. Get 7.2. For XZ, I get -3 minus 1 plus -8 minus a -2 makes it a +2. And I get 7.2. So for this, the diagonals are congruent. So I'm going to think, are rhombus diagonals congruent, or is the square diagonals congruent? Looking at my cheat sheet and thinking of the properties, squares have all 4 sides congruent and their diagonals are congruent as well. If you have questions, let us know.